going to cover the most basic of trigonometry. And we are going to call it, you're going to remember this. SOHCAHTOA, which is like, when I was a kid and my grandma saw like I had a toe fungus, she's like, hey, go in there and make sure you soak your toe, right? That's what it all stems from. But here's the idea. It just gives you ratios, which are fractions. So this SO says sine equals the opposite over hypotenuse. And you'll see what this means. This is what we're practicing today. The CA part is cosine is equal to the adjacent side over the hypotenuse. And again, we'll talk about that in a minute here. And then TOA stands for tangent. It's going to be equal to the opposite over adjacent side. So we're going to be dealing with right triangles here. And the opposite and adjacent sides are kind of depending on which angle you're looking at. The hypotenuse is always the one across from the right angle. It's always the longest side. It's the only side that doesn't touch the 90-degree angle. So let's try out some of these problems. Use the triangle below, find sine of A, cosine of A, and tangent of A. So we're looking at angle A over here. If we're doing the sine of A, I know that sine, according to SO, is the opposite side over the hypotenuse. The opposite side is the only side that's not touching this angle. So in our case, that's going to be 5 over the hypotenuse is the side across from the right angle. So it'd be 5 over 13. Double check, see if you can simplify that at all, which you cannot. So that's it. I know, you thought it was going to be worse. Now we're going to try cosine of A. Now the CA says that you do the adjacent side over the hypotenuse. We already know the hypotenuse is 13. The adjacent side is the side between the angle and the right angle. It's the non-hypotenuse side that is touching the angle. Okay, so in our case it would be 12. Great. And then tangent. Tangent is the opposite side over the adjacent side. So this opposite side is the side it's not touching over the adjacent side, which is the side between the angle and the right angle. So 5 over 12. You always have to make sure you reduce the fractions if you can. Okay? So let's see. I think use the triangle in example 1. Find the sine of B, sine, cosine, and tangent of B. Very similar. We're just referencing a different angle here. So we're going off of B. So the sine of B would be the opposite, which is 12, over the hypotenuse, which is 13. Cool. Then we will do the cosine of B. Cosine is adjacent, which will be 5, over the hypotenuse, so 5 over 13. Great. And then tangent is the opposite side, 12, over the adjacent side, 5. So part B says, what is the relationship between sine of A and cosine of B? If you look at sine of A, 5/13. Cosine of B, 5/13. Huh, it's interesting, they're the same. And when you get into geometry and algebra 2, you'll kind of explore that relationship a little bit more.